Hello everyone, welcome to my channel Chemical Engineering Knowledge. In this lecture we will discuss about some important topics of the mass transfer about the distillation. So first we will discuss the material balances. Material balances in the flat column. Material balances in flat column. Then we will define the operating line equation. Operating lines equation. Then we will determine the number of layers. Number of layers using McCabe Thiele method. So let's start. In the previous lecture we have discussed that this was our distillation column. This is the feed. Feed was entering to distillation column. This was the top product, distillate. This is the bottom product. And these are the number of layers in the distillation column. Above the feed plate, we said that above the feed plate this section is called feed is put into this. So we say that above the feed plate the section of the distillation column is called the rectifying section. And we said that below the feed plate, including the feed plate, this is the feed plate, this one. So below the feed plate and including the feed plate, this section of the distillation column is called the stripping section. So this is the rectifying. This is the rectifying section of distillation column, and this red one is the stripping section. This one is the stripping section of the distillation column. So now the general material balance for this distillation column, or the overall material balance for this distillation column is this yellow one. So the feed is entering to distillation column, and the top product and bottom product are continuously removed from the distillation column, from top and bottom respectively. So the material balance, the general material balance is feed is equal to D plus B. D is for the distillate and B is for the bottom product. So B is for the bottom product. Now this is the general material balance equation. Suppose 100 mole of feed is entering and 60 mole vaporized, and 40 mole come to the reboiler. So 100 mole is entering, 60 mole come out from the top, 40 mole come out from the bottom. So this is the simple material balance equation. Now what will be the component balance? So we are introducing a feed to the distillation column. We are introducing feed to the distillation column. We are introducing feed to the distillation column. We are introducing feed to the distillation column. So this is our distillation column. This is the feed. This is the distillate, and this is the bottom product. This is the feed. So the overall balance is F is equal to D plus B. Now what will be the component balance? So suppose we enter a feed to the distillation column. the cube mixture consists of component A and component B. So we enter the cube to the distillation column, which is a mixture of two components, component A and component B. Suppose component A is more volatile component, component B is less volatile component. So more and more, more volatile component will obtain from the distillate, and the less volatile component will obtain from the bottom product. So this is a mixture. Suppose we enter a mixture of component A plus component B into distillation column. Component A is more volatile, component B is less volatile component. Suppose mole fraction of component A in the liquid mixture is XA, and the mole fraction of the less volatile component in the mixture is XB. Similarly, the mole fraction of more volatile component in the distillate is XB, and the mole fraction of more volatile component in the bottom is XB dash. So this XB is the mole fraction of this XB is the mole fraction of less volatile component in the liquid mixture, which is coming to the distillation column, and this XB dash is the mole fraction of more volatile component in the liquid. This XD is the mole fraction of more volatile component in the top product. So this the mole fraction of more volatile component in the distillate, RD, is denoted by XD. Similarly, the mole fraction of more volatile component in the bottom, RB, is denoted by XB dash. So don't confuse this XB dash and B. XB is the mole fraction of less volatile component in the cube, and XB dash is the mole fraction of more volatile component in the bottom product, RB. So this was the all material balance. Now on the basis of the material balances on the basis of more volatile component is this is the now material balance on the basis of material balances on basis of more volatile component A. So material balance on basis of A is, this is the F, and this A is equal to D XD plus D XB dash. So now how can we obtain the cube to distillate ratio? How can we obtain the cube to bottom ratio? So the cube to distillate and cube to bottom ratio can be obtained from these two equations. This is equation 1, equation number 2. Now how can we obtain these two ratios? So this is equation number 2. So equation 2 can be given as F is equal to Fxa is equal to, in place of D we can write F minus D. In place of this D we can write F minus D from this equation number 1. So we will write F minus D XD D XD. So in order to find the F by B, therefore we will write F minus B in place of D in this equation number 2. So for this simplify, Fxa is equal to Fxd minus Bxd plus Dxd dash. Now further simplify this equation. Fxa minus Fxb is equal to Dxb dash minus Dxb. Xa minus Xb Dxb dash minus Xd. by b is equal to xb dash minus xb divided by x a minus xb. So this is f by b, feed to the bottom ratio. Now how can we obtain feed to distillate ratio, feed to d ratio? So first we will find it, feed to the distillate ratio. So we will find it here. So how can we find? No, we will find it here. So in order to find the feed-to distillate ratio, so this equation can be written as fxa is equal to dxb. Now in place we will remove this b. In place of b we will write f minus b, because f minus b is equal to b from this equation 1. So f minus b into xb dash. Now further fxa is equal to dxb xb dash minus dxb dash. Further simplify this equation, fxa minus fxb dash is equal to fxa minus fxb dash is equal to dxb minus dxb dash. So this is f xa minus xb dash is equal to dxb minus xb dash. So f, this is f divided by d, feed to distillate is nothing but xb minus xb dash divided by xa minus xb dash. So some author write xf in the place of this a and xp in place of this xp dash. So you can write this equation also like xb minus xb xf minus xb. So it depends on your calculation. As you wish, you can write this form or this form. So you can write both forms, which depend on your calculation. Similarly, in the above, f by b ratio, you can also write xf in place of this xa, and you can write xp in place of this xp here. So don't confuse with these two terms. Now, what will be the operating line equation in the distillation column? So, what will be the operating line equation in the distillation column? Operating line equation. Okay. Operating line equation in the distillation column. So we have already discussed that this is our distillation column. Suppose this is our distillation column. This is the top product, this is the bottom product, and this is the feed. So this is feed A1, A2, this is A3, A4, this is A5, A6, A7. So we will start numbering from this upper side, 1, 2, 3, 4 up to n, n. And above, if there are n number of plate, then suppose this is n number of plate, this. Above the feed plate, this is the feed, and this is the feed plate, this one. So above the feed plate we will write N. This is N number plate number N from the upper side. And suppose this is plate number N. So in order to distinguish between the two sections, the rectifying section and the stripping section of the distillation column, we will write N for the stripping section, for the rectifying section, and we will write N for the stripping line equations. So don't confuse these two. So for the rectifying section or for rectifying equation we will write N, and for the stripping equation we will write M. So suppose we consider this plate N. So we will apply the material balance on plate number N in the rectifying section. So in order to apply material balance to a single plate, then we will say that to a single plate, two stream is coming to a plate. One is from the, suppose this is N plate, this is N minus 1 plate, and this plate is N plus 1 plate. Similarly, suppose this is plate number N, this yellow plate N, this is N minus 1, and this is N plus 1, N plus 1 plate. So first of all, we will write the rectifying section equation. So we will write rectifying section equation. So we will derive the rectifying section equation. So how can we derive the rectifying section equation? So we say that to a single plate, to this, if we apply material balance on this plate number N, then we will say that to this plate number N, two stream is coming. One is coming from the top and one is coming from the bottom. So the feed coming from plate N minus 1 will be in liquid form, and the feed coming from plate N plus 1 will be in vapor form. So the molar flow rate of this feed which is coming from the plate N minus 1 will be N minus 1, and the molar flow rate of feed which coming to plate N from N minus 1 plate will be the molar flow rate of the feed which coming from plate N plus 1 to plate N will be Vn. This is Vn. So this will be Vn. Similarly, two stream are the two stream leaving this plate number N. So one is this stream, this stream leaving the plate, and this stream is also leaving the plate number N. So now what will be the, this is in liquid form, and this feed is in the vapor form. So the molar flow rate of this stream will be written as Ln, and the molar flow rate of this vapor which are coming from plate number N to plate number N minus 1. So the molar flow rate of this stream will be Vn. This will be Vn. So molar flow rate of this stream is Vn. So this is the molar flow rate of this stream, Vn. Now what will be the material balances? So let us consider in order to derive the stripping down equation. Now, in order to derive the stripping down equation, we will apply material balances on this upper section, this stripping section. So, use a control area, control surface. This surface 1 is for the stripping, is for the rectifying section. Sorry, this area 1, this control area is for the, this control surface is for the rectifying section. So what will be the material balance in this green line? So what will be the material balance in the upper section on the distillation column, or what will be the material balance in the rectifying section on distillation column? So what will be the material balance? If this distillate is coming out from this envelope, this area, V is coming out, L is coming out, but Vn is entering. So Vn is entering. So this is not Vn, but this is Vn plus 1. The vapor which is coming from air number n plus 1 will be denoted by Vn plus 1. This. So what will be the material balance? Two streams D and L are coming out from this area, and one stream Vn plus 1 is entering to this surface. So what will be the material balance? Vn plus 1 is equal to Ln plus D. This is important equation. So this is, suppose this is equation number 1. This is equation number 1. Now we are using Ln, we are using Vn, we are using Ln, we are using Ln minus 1. So the mole fraction of this Ln stream is Xn. For liquid we are using X, and for vapor we are using Y. So Ln, the mole fraction of Ln stream is Xn. Similarly, the mole fraction of Vn stream is Yn. Similarly, the mole fraction of Ln stream is Xn, and the mole fraction of Vn stream is Yn. Similarly, the mole fraction of Lm minus 1 stream will be equal to Xn minus 1, and the mole fraction of Vn minus 1 stream will be equal to Yn minus 1. So don't confuse. So these are the mole fraction. These are the mole fraction. These are the mole fraction. These are the mole fraction of these streams. And these streams. So these are the mole fraction. Now what will be the rectifying section equation? This is the rectifying section. What will be the equation for this rectifying section of the distillation column? So Vn plus 1, and the mole fraction of this Vn plus 1 stream will be equal to Yn plus 1 is equal to Ln, and the mole fraction of Ln stream is Xn plus D, the distillate, and the mole fraction of distillate is nothing but Xd. Now further simplify this. Suppose this is equation number 1, and this is equation number 2. Simplify equation 2. Yn plus 1 is equal to Ln Xn divided by Vn plus 1 plus D Xd divided by Vn plus 1. So This equation is called the straight line equation for the rectifying section of the distillation column. So we can also say that the vapor coming from plate N plus 1 will be equal to the vapor coming from the plate N, and it will be equal to V. So during steady state operation, when there is no heat loss from the distillation column and there is no enthalpy change of mixing, then Vn plus 1 will be equal to Vn. Similarly, Vn plus 1 will also equal to Vn. Similarly, Lm minus 1 will be equal to Lm when there is no heat loss or gain during the mixing process, or when the heat loss during condensation is equal to the heat of. So when the heat of condensation is equal to the heat of vaporization, then in that case Vn plus 1 will be equal to Vn, or Vm plus 1 will be equal to Vn. So these are the some terms. So this equation can also be written as Yn plus 1 is equal to Ln Xn, and in place of Vn plus 1 we will write Vn. This is dXd, and this is Vn plus Vn. So this is because Vn plus 1 is equal to Vn. So this is Vn. So this equation is called the straight line equation of the rectifying section of the distillation column. Now, what will be the stripping section equation? This is the stripping section, this one. So what will be the straight line equation for the stripping section of the distillation column? So now we will derive the straight line equation for the stripping section of the distillation column. Derive the straight line equation for the stripping section of the distillation column. So this was the feed. Now suppose consider this plate M. So again two stream is coming to plate N. One is this feed and one is this feed. Two stream is coming out, one is this and another is this. Two stream are coming to this plate number M, and two stream are leaving out this plate number M, just like plate number M. So the liquid which coming to plate number M from plate number N will be equal to Ln minus 1. Ln minus 1. Ln minus 1. Ln minus minus 1. This is Ln minus 1. Similarly, the liquid leaving the plate number M will be equal to Ln. Ln. Similarly, the vapor which coming from plate M plus 1 to plate M will be equal to Vm plus 1. Vm plus 1. It will be equal to Vm plus 1. So similarly, the vapor which coming out from plate number M to plate number, so the vapor which coming from plate M toward the plate M minus 1 will be equal to Vm. These M and N are given to the feed. The feed which leaving the plate, then suppose if a feed leaving plate M, if a liquid leaving plate M, then it will be written as Ln. If a vapor leaving plate M, then it will be written as Vn. If a liquid leaving plate M, then it will be written as Ln. If a vapor coming to plate M, then it will be written as Vn. Similarly, if a liquid leaving plate M minus 1, it will be written as Ln minus 1. Similarly, if a liquid leaving plate, if a vapor leaving plate M, then it will be written as Vm. So these are on the basis of plate. These M and N come with the V and L, which are given to these feed on the basis of the plate. So now what will be the material balance on plate number M? So 2 stream are coming to plate M and 2 stream are leaving the plate M. Now what will be the material balance? So suppose we are considering this in below this section, including the bottom product. So what will this is the given, this is leaving. So suppose this is the control area. This is the control area or the control surface 2. Control surface 2. This was the control surface 1, and this is the control surface 2 is for the stripping section. So what will be the material balance? Is what is entering to this surface? What is entering to this surface? What is entering to this surface, and what are leaving this surface? So the Vm leaving this surface, and the V are also leaving, and Lm minus 1 are entering. So what is the material balance? Lm minus 1 is equal to Vm plus V. This is the important equation. Suppose this is equation number 3. Now what will be the component balance in this stripping section on the basis of more volatile component? So it will be written as Ln minus 1 into Xn minus 1 is equal to Vn Ym plus Vxb. Vxb dash, remember in the first so this is the Vxb dash, this is the xb dash. In the start of this lecture we have discussed that the mole fraction of this V will be mole fraction of more volatile component in this proton will be xb dash. So in the mole fraction of more volatile component the Q was x dash. So don't confuse these two. So what will be the, how can we further rewrite this equation? So it can be written as Ym is equal to Lm minus 1 into Xn minus 1 minus Vxb dash divided by Ym is equal to Lm minus 1 Xm minus 1 minus Vxb dash divided by Vm, and this is also Vm. Now this is this equation number, suppose equation number 4. This is equation number 4. This equation number 4 is the straight line equation for the stripping section of the distillation column. So this is the stripping section equation. Now we can if the constant molar flow rate on the basis of constant molar flow rate, similarly when the heat from the distillation column is 0 and when the heat of condensation is equal to the heat of vaporization in the distillation column, then in that case Ln minus 1 will be equal to Ln, which we should already discuss. So like this, for the rectifying section we write this relation. For stripping we can write this relation. So in place of Ln minus 1 we can write Ln. So Ln xn minus 1, xn minus 1, and this is v n minus p xp dash divided by vn, 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 and this is yn. So this equation is for the this is the equation of straight line for the stripping section of the distillation column. Now this equation is for the this is the straight line. This equation is a straight line equation for the rectifying section, and this equation is the straight line equation for the stripping section. Now what will be the slope of the rectifying line equation? So the slope of the rectifying line equation, the slope of the rectifying line will be this. This will be the slope of the rectifying line, and this will be the y-intercept of the rectifying line. Similarly, this will be the slope of the stripping line, and this will be the this will be the y-intercept of the stripping line. This will be the slope. This is the slope of the stripping line, and this is the y-intercept of the stripping line. This is the slope of the stripping line. This is the y-intercept of the stripping line. This is the slope. Similarly, this is the slope of the rectifying line, and this is the y-intercept. This is the y-intercept of the rectifying line. So these two equations are very important for us in order to determine the number of plate using McCabe Thiele method. So we will use these two equations in this lecture further. So these two equations are very important. So we will write these two equations which are very important. Up to now we obtained two equations which are very important to us. One is the rectifying equation and the other is the stripping line equation. So these two equations we will further write. These two equations are very important. So we will write these two equations for the rectifying section. Rectifying section, the straight line equation will be yn plus 1 is equal to ln divided by vn into xn. This is plus d into xd divided by vn. And for the stripping section, the equation will be for the stripping section. the straight line equation will be yn will be equal to ln divided by vn xn minus 1 minus bxb dash divided by, in some book this xb dash, in place of this xb dash they write xb, so don't confuse. Now this is the for the stripping section and this is for the rectifying section. Now now let's come to the rectifying section, the straight line equation for the rectifying section. So in place of xn, if we put in the case of constant molar flow, xn is equal to xd, and similarly xn minus 1 is equal to xd. So when xn is equal to xd in this equation, then what will be the yn plus 1. So if we write xd in the place of this xn, so in place of xn we write xd, what will happen? So this equation will become yn plus 1 will be equal to ln vn xd plus d xd divided by vn. This xd will come out, so it will become ln plus d, and this will be vn. This is ln plus d, this is vn, this is d, and this is x d, and this is equal to y n plus n. So this ln plus d is nothing, ln plus d is nothing but it is vn. Vn is we have already obtained. So this vn cancels with this vn, and it is equal to 1. So yn plus 1 will be equal to xd. So y is equal to x. Y is equal to x. So if we put xd, then y1 plus yn plus 1 will be equal to. So if we put xd, the xd in the place of this xn, then what will be yn plus 1? Yn plus 1 will also become equal to xd, as we have derived in this equation. So this is the x, and this is the y is also x plus d, because this is the coordinate of a point is xy. So x in place of xd, in place of xn, we put, when we place d in place of xn, this is the x point. So when we put xd in the place of xn, then the yn plus 1 will become equal to xd. So the y and x become equal. This is one point on the rectifying line, and this line, and this is the slope of the rectifying line. This is the y-intercept of the rectifying line. Similarly, for the stripping case, when xn minus 1 is equal to xd, mean when the mole fraction of more volatile component which are leaving plate M will be equal to the mole fraction of more volatile component which are coming here in the bottom, xp. So when xn minus 1 is equal to xb dash, then what will be happen? This is xp dash. This means that when the mole fraction of more volatile component which are leaving the plate M minus 1 is equal to the mole fraction of more volatile component which are leaving the bottom of this distillation column. So what will happen to this stripping line equation? This yn will be equal to xp dash. So in place of xn minus 1, I put xp dash. xp dash and xp dash will be common out, and lm minus p is nothing but it is vm. So lm minus p is nothing but it is vm, and this vm will cancel with this vm. So yn will be equal to x b dash, just like we have derived this one. So if xn minus 1 is equal to x b dash, then what will happen to this equation? This yn will be equal to xn x b dash vm minus b x b dash divided by vm. Now this x b dash will come out, this x b dash and this x b dash will come out. So yn will be equal to this equation will be equal to yn is equal to ln minus b into xp dash divided by en, and this Ln minus b is nothing but it is Vn. So this Vn will cancel with this Vn and y will be equal to x. So again one point will occur on the stripping line, which is xb. So this which is xb dash, sorry. So this is the x point, this is the x point, and this is the y point. Yn is the y point. So y point become equal to the x point. So both the point x and y points become equal. So these x is xb dash and y is also become, and yn is also become equal to xb dash from this equation. So y is also become equal to xb dash. So this is one point on the stripping line. So if we know this point on the stripping line, and if we know either the slope of the stripping line, or if we know the y-intercept of the stripping line, then we can draw the stripping line. So if we know this point on the stripping line, and if we know the y-intercept of the stripping line, then we will draw the stripping line in the McCabe Thiele method. Similarly, if we know this point on the stripping line and the slope of the stripping line, which is this Ln divided by Vn, then we will draw the stripping line. Similarly, for the rectifying section, if we know this point on the rectifying line, and if we know the slope of the rectifying line, which is this slope, then we will draw the rectifying, which is this slope, Ln divided by Vn, Ln divided by Vn, then we will draw the rectifying line. Or if we know this xd comma xd, this point, and the y-intercept of this rectifying line, then we will draw the rectifying line. Because in order to draw a line, we either need 2 points to draw a line, or we need 1 point and slope of the line to draw a line. Or we can also draw a line by knowing 1 point and the intercept, y-intercept. So if we know the y-intercept and 1 point, then we can draw a line through that. So this point, through this y-intercept and this point. So now we will come to the McCabe Thiele method. So for the McCabe Thiele method, we will draw the these two equations. Remember these two equations. This is for the rectifying section and this is for the stripping section. Now what will be the McCabe Thiele method? So the McCabe Thiele method is very important method in order to find the number of plates in the distillation column. To find the number of plates in the distillation column, we will use the McCabe Thiele method. So what will be the McCabe Thiele method? McCabe Thiele method. So again, these two equations are very important. One is the stripping line, one is the rectifying line. Yn plus 1 is equal to Ln Vn Xn, and this is the d xd. This is the Vn. And is this equation, and for the stripping line, Yn is equal to for the stripping line, Yn is equal to Ln divided by Vn, and this is Xn minus 1, and this is minus b x q dash divided by Vn. So these are the two important equations. So these are the two important equations in the distillation process. So remember these two equations in the distillation process. These two equations are very important in the distillation process. So sorry, this is not M, but this is N, because in the rectifying section we are using M. So sorry for this. This is not M. This is N. This is N. This is N. Everywhere in the rectifying section we will use N. We will not use M, because we have already said that for rectifying section we are using N symbol, and for splitting section we will use the M symbol. So this is yn plus 1, not yn plus 1. So yn plus 1, and this is yn. This is for the splitting one. So these two equations are very important. Now, how can we draw the number of plates using the McCabe Thiele method? How can we draw the number of plates using the McCabe Thiele method? So McCabe Thiele method. Thiele method. So the first point in order. So there are some assumptions for the McCabe Thiele method. There are various assumptions. So McCabe Thiele method is very simple. The first assumption for the McCabe Thiele method is that the heat from the distillation column, the heat removed or heat absorbed to the distillation column will be 0. There will be no heat removed or no heat absorbed to the distillation column. Similarly, the second assumption is that the heat of condensation will be equal to the heat of vaporization. So when the less volatile component are condenses to the liquid from the vapor state, then the heat released during this condensation process will be equal to the heat which are absorbing the less volatile component of the liquid to form the vapor. So the heat of condensation will be equal to the heat of vaporization. This is the second assumption. And the third assumption is the constant molar flow. So constant molar flow means that Vn plus 1 will be equal to Vn. Similarly, Vn plus 1 will be equal to Vn. Xn minus 1 will be equal to Xn. This will be equal to X B dash or Xb. Similarly, Xn minus 1 will be equal to Xn. It will be equal to Xb. So these are the constant model. Vn will be equal to V, F will be also equal to V. Similarly, Ln will be equal to Ln minus 1, and F will be equal to L. Similarly, Ln minus 1 will be equal to Ln, F will be equal to L. So this is the constant molar flow assumption. So these are some assumptions of the, and there will be no enthalpy change when you determine the number of layers during the McCabe Thiele method. So these are some assumptions of the McCabe Thiele method. How we determine the number of layers using McCabe Thiele method? What will be the procedure? To find the number of layers using the McCabe Thiele method? So the procedure is very simple. So first of all, we will draw the draw xy plane, xy plane. Then draw the diagonal line, the diagonal line. Then draw the equilibrium line, equilibrium curve. Then draw the rectifying section. Draw the rectifying line. Then draw the stripping line. Then determine the number of plate. So this is the simple method. These are the steps and the procedure. Okay. So first of all, draw the xy plane. This is the xy plane. Draw xy plane. Yes, you draw the xy plane. This is x. This is y. Then draw the diagonal line. What is the diagonal line? It is the straight line. This is the diagonal line. This is the diagonal line which is formed at 45 degree. This is the diagonal. This is our diagonal line. If this diagonal line, x is equal to y. This is the diagonal line. So this is the diagonal line. First of all, we plot the xy plane. Then draw the diagonal line, this line. Then draw the equilibrium curve. So we draw the equilibrium curve. Now this equilibrium curve is obtained from the equilibrium data or from relative volatility relation. What will be the relative volatility relation? It will be equal to YA is equal to the relative volatility of AB into XA divided by 1 plus relative volatility of A into B minus 1 into XA. So this will be the relation, or it can be determined from this relation. This is the x, and this is the YA. This is the XA, and this is the YA. This is the XA, this is YA. So if we know the relative volatility, and if we know the X composition of more volatile component in the liquid, this is XA. This is YA. So if we know relative volatility of AB mixture, and if we know the composition of more volatile component in the liquid, then we will determine YA, and then we will plot this point and this point on a graph, and we will obtain a curve like this, which is called the equilibrium curve. This is the equilibrium curve. This curve can also obtain from this relative volatility relation like this. Relative volatility of AB is equal to volatility composition of A in the vapor, composition of B in the liquid. So we obtain from this relation like the relative volatility of AB is equal to composition of A in the vapor, composition of A in the liquid, divided by composition of B in the vapor, composition of B in the vapor, composition of B in the liquid. So rearrange this equation, we will obtain this equation by using the relation that YA plus YB is equal to 1 and XA plus XB is equal to 1. If we sum is interested to find YB, then YB will be equal to 1 minus YA, XB will be equal to 1 minus XA. So sum of mole fraction is equal to 1. This is the relation. Now we have determined the equilibrium curve. Now how can we obtain the rectifying line? So in order to find the rectifying line, we have already discussed that in order to draw a line, 2 points must be needed. Either 1 point or slope must be needed, or 2 points must be needed. So if we know XD, XD, suppose if we put in the place of xn, suppose if in the place of xn we put xd, then this will be equal to y will be equal to x, and we will obtain a point like xd, xd, as we have already obtained. This is xd, xd. So xd, xd. If we put xd in place of this xn, then we will obtain that yn plus 1 will be equal to xd. So y will be equal to x, and the x is xd and the y is also become xd. So we will obtain this point. So if we know this point and if we know the y-intercept, the y-intercept is nothing but it is the d into xt divided by vm. If we know the molar flow rate of vapor which are coming from plate M, and if we know the mole of distillate, and if we know the mole fraction of more volatile component in the distillate, then we will obtain the y-intercept by this relation d into xt divided by vm. So the y-intercept, this is the y-intercept. So if we know obtain this y-intercept, then we will combine this point and this point. We will draw line. This is called the rectifying line. Rectifying line. We can also find this rectifying line by this point xp comma xt and the slope ln divided by vn. So the slope of this line is ln divided by vn. ln is nothing but the molar flow rate of liquid which are leaving the plate M, and vn is the molar flow rate of vapor which leaving the plate M. Similarly, for the stripping line, we will find for the stripping line 2 points will be needed, either slope or 1 point or 2 point. So if we put xp in the place of this xn minus 1, we will obtain that yn will be equal to xp dash. So if we put xp dash in place of this xn minus 1, we put xp dash in this place, we will obtain that yn will be equal to xp dash. So this is the end point, xp dash, xp dash comma xp dash, xp dash. Dash xp dash comma xp dash. So this point, and if we know the y-intercept, b minus b divided by bm into xb dash. So if we know the mole of the bottom product, if we know the mole of vapor which are leaving the plate M, and if we know the mole fraction of more volatile component in the bottom, then we will obtain the y-intercept. The y-intercept is nothing but it is minus b into xp dash divided by vm. So how can we obtain? This is this y-intercept is negative, so it will come to the downward side, to the minus sign, because this is the xy plane. This is the xy plane, this is the left x, this is minus x plus y minus y. So the y-intercept will be occur at this point. So now the y-intercept occur at this point. Now connect these two points. Connect to the this is the stripping line. So this is the stripping line. This is straight line. This straight line is called the stripping line. Now after draw the stripping line, it is very simple. After draw the stripping line, come to this point. Either we can count from the top or we can count from this bottom. So come to the top from this, come to the equilibrium line from downward into this side, downward, this side, downward, this, downward, downward. So here there are how many number of plate? This is plate number 1, this is plate number 1, this is plate number 2, plate number 3, plate number 4, and plate number 5. So 4.2 are approximately 5 number of plate. 5 plates are required for the distillation by McCabe Thiele method. So this McCabe Thiele method is very simple. So just for your information, first of all we draw the XY plane. First of all, draw the XY plane. Draw the XY plane. First of all, draw the XY plane. XY plane. This is the XY plane. Draw the straight line. Draw the equilibrium curve. After it, find the distillate point XPXD. XPXD is nothing but this point, straight this point. XPXD. Then find the y-intercept of the rectifying line. Connect these two. Then find the bottom position XPXD from the stripping line. This is obtained from the stripping line, and this is obtained from the rectifying line. Similarly, this is obtained from the rectifying line. So find this XPXD. Also determine the y-intercepts for this or this, or you can suppose this is this point, and suppose this is the first of all find this XPXD, then find the y-intercept at the stripping line, or find the slope of the stripping line. Suppose you determine the y-intercept, so connect these two. Now connect these two. Connect the stripping line with the rectifying line, and then start the number of plate numbering. You can start from this side or from this side. So start from this side, from this point to the equilibrium curve, from downward, so this. So it's plate 1, plate 2, plate 3. So 3 number of plate is 3 from McCabe Thiele method plus 1 reboiler. So this is the McCabe Thiele method. Thank you very much for your attention.